to be mostly practical. So you should get your book and pen ready so that when the question comes, you can solve and send me the reply as fast as possible, okay? Because today you are going to do a lot of solving of questions. How many of you have done mensuration before? Mensuration 1, I mean circles. How many of you? Give me a yes if you have done it before in the chat box. If you haven't, to give me a no in the chat box. Hello, can you hear me? If you have, give me a yes. If you haven't, give me a no. Okay. Hey. Michael Fosu, capital no. Wow. Owen, no. Daniel, no. Okay. Abraham, Brigita, Lisa, no. Okay. Who else? Kelvin. Kelvin, are you around?
Yes, sir.
Yeah, is it a yes or a no? Have you done mensuration before?
No, sir.
Oh, okay, okay. Wanted to know if everyone is around. Okay, so we can continue now. Okay, so mensuration is all about area and perimeters of shapes. And the shapes, it starts from simple shapes and we gradually enter into the complex shapes and other shapes. So we will start from the simple ones. We start with circle. I know that you all did circle in JHS, right? I know that you all did circle in JHS because I'm teaching someone circle in JHS at the moment. So I know that you have done circle in JHS. Okay. So we are going to start off with part of a circle, which is very simple for all of you. I know very well that it's very simple for all of you. Okay, so let me see if I can move this. Okay, so we are going to talk about part of a circle, and I'm going to use this circle, okay, to explain things better for you. Okay, so the circular part of the circle is called the circumference. The circular part, this brownish something, is called the circumference, okay? The circular part is called the circumference. Any part of the circumference is called an arc. So this whole thing is called the circumference. This part, oh, sorry. This part will be called what? An arc. This part will be called an arc. Now, a straight line joining 2 points on the circumference is called a chord. But before that, any straight line moving from the center of the circle to any side of the circle is called a radius. Is that okay? I think I forgot to add that one. Any line that moves from the center of the circle to the circumference of the circle is called a radius. And a chord is a line joining 2 points on the circumference of the circle. So as you can see, the chord does not join 2 points. It moves from not the chord. The radius does not join 2 points, but it moves from the center of the circle to 1 point of the circle. That's the radius. Now the chord joins 2 points. That is, this point is 1 point, and this is another point on the circumference of the circle. on the circumference of the circle. So the chord joins 2 points. That's it moves from one circumference of the circle to another circumference of the circle. That is the chord. 1 second. That is the chord. Okay. That is the chord. Now, after that, we would like to talk about the diameter. The diameter. Now, a diameter is a chord. A diameter is a chord that passes through the center of the circle. So if the chord passes through the center of the circle, it is called what? A diameter. So as you can see, this chord is moving from one side of the circle to another side of the circle, but it is passing through the center of the circle. Now there's another chord that can pass through. It also touches the circumference of the circle, but it doesn't pass through the center. So that's the difference. The diameter passes through the center of the circle, and the chord, it is a chord. The diameter is a chord, but it just passes through the center of the circle, and that makes it special. So that's why it is called a diameter. And the normal chord, it touches any part of the circumference. So if it moves from here to here, it is a chord. If it moves from here through the center to here, it is what? A diameter. So that's the difference. Take note. Okay. Now the distance from the center of the circle. Okay, I added it. From the center of the circle to the circumference of the circle is called a radius, which I've explained earlier. That's the distance from the center of the circle to the circumference of the circle. It's called a radius. Okay. Now, a chord divides the circle. A chord, it divides the circle into 2 parts. As you can see, this chord that I'm drawing is dividing this circle into 2 parts. Each of these parts are called segments. So if a chord divides a circle into 2 parts, it's called what? The area here and the area here is called a segment. Now, the smaller parts, which is this side, the shaded region, is called a minor segment. It is called a minor segment. And the bigger part, which is this side, the unshaded region, is called a major segment. So that's also what we term by segment. A segment is an area that has been divided by the chord in a circle. So this part is a segment, this part is also a segment, just that this part is a minor segment and this unshaded region is a major segment. Now, the area bounded by 2 radii of a circle is called the sector. Okay, let me explain this one. So we have one radius moving from the center of the circle to the circumference of the circle. And we have another radius moving from the center to the circumference of the circle. Now, if you have one, it is called a radius. If you have 2, it is called radii. Radii. So that's the difference. If you have one, it is called radius. If you have 2, it is called radii. Now, the area in between these 2 radii, which is this side, this shaded region where I'm shading, this area is called a sector. So the area bounded by 2 radii of a circle is called a sector. The area bounded by 2 radii of a circle is called a sector. Is that okay? So you have to take note of that one too. Now, 1/4 of the circle is called a quadrant. Now, the circle can be divided into 4 equal parts. as you can see from this diagram. So a quarter of this circle, which is this part, is called a quadrant. So this is a quadrant, this is another quadrant, this is another quadrant, and this is another quadrant. So a quarter of the circle is called a quadrant. And half the area of a circle is called a semicircle. That way we know from kg. Is that okay? When a circle is divided into two, it is called a semicircle. It is called a semicircle. So at this point, any question? If you have a question, you can give it to me in the chat box. You can raise your hand, I will mute you, then you start talking. Or you can give me a no if there is no question. If there is no question, give me a no in the chat box. Hello? Good, 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 good. Okay, no from only 2 people. Okay, 3, 4, 5, 6. We have 9 participants. 6 at the moment. Okay, that's majority. We can continue. Okay. Okay, 7. So, after knowing this part of the circle, now we have to know the perimeter and the area of a circle, how to calculate for them. Okay, so how to calculate for the perimeter and the area of a circle. How to calculate for the perimeter and the area of a circle. So first we take the perimeter of a circle. Now I hope you know perimeters and areas, right? They are from JHS. Perimeter of a circle, area of perimeter of a rectangle, area of a rectangle, perimeter of a square, area of a square. It's the same thing here. Is that okay? Okay, so let's start something. So the circumference of the circle is called the perimeter, or the perimeter of a circle is called the circumference. So when you are asked to find, the perimeter of any circle, you are being asked to find the area around the circumference. So the circumference of the circle is called the perimeter. For example, this is a circle, right? You see it as round. You see it as round and everything. And they are telling you to find what? The circumference, that's the perimeter of this circle. Now, if you are able to make this circle a straight line and draw it in a straight line form, the length of this straight line will be termed as the perimeter of this circle, right? So the perimeter of the circle, which is this line, as I've drawn it as this, is what we are looking for. So whenever you are told to find the perimeter of a circle, you are being told to find the length of that circle. The length of that circle. So if this circle is a straight line, we are looking for what? The length of that straight line. The length of that straight line. Is it 20 centimeters, 30 centimeters, is it 40 centimeters? That's what we are talking about. The length of that circle. Okay. Good. 1 second. So finding the circumference of the circle, there's a formula for that. I know during your JHS, oh, 1 second. You will do something on that. That's finding the circumference of the circle. But you had a formula that you worked with, which is what? Pi, which is 2 pi r. This is the formula that we were working with, right? So we would like to know how this formula came by and why there is a pi even there. Why there is a pi even there. Okay. So the circumference of a circle, which is 2 pi r. Okay, let's take an example. You have a radius of 2 and you are being told to find the circumference of the circle. Is that okay? Now it will be 2 by 22 over 7.
Times 2.
22 over 7 by 2, right? That's what you do.
Yes.
Good.
12.5714.
Good. So that will give us 12.57. That will give us 12.57. Is that okay? Now,
Yes.
if you pick this 12.57 and you divide it by the diameter of the circle. Now, as you know, the radius is from one side of the circle to another side of the circle. So the diameter passes through the center of the circle. Therefore, the radius, having two radiuses makes one diameter. Is that okay? Having two radiuses makes one diameter. So one radius moves from here to the center. And another radius moves from the center to this side. And that is what? A diameter of a circle. Therefore, if we divide this 12.57, we divide it by 4. Is that okay? We'll be getting a certain figure. That will give us 3.14. Sorry, I don't know why today my mouse is fooling. Is that okay? We'll be getting 3.14. Now, if you are given the radius of any circle and you are being asked to find the circumference, and you find the circumference and you divide that circumference by the perimeter, the diameter, you'll be getting what? 3.14. For example, solve it on your calculator. We have a radius of 2.5. We have a radius of 2.5, so it will be 2 times 22 over 7 times 2.5. And that will give us what? 15.7142 something something something. You divide that one by the diameter. 2.5 times 2 give us what? 5. So if you divide that one 2 by 5, you'll be getting what? 3.142. And it is the same in every circumstance. Therefore, bringing us what? The pi, which is the missing figure in this equation. Is that okay? Therefore, that's how the pi came by. So we'll be having what? 2 times 3.142 times the radius. Always to find what? The circumference of the circle. So the formula for finding the circumference of the circle is what? 2 pi r. This side I don't have the pi, so I normally represent it with x. Is that okay? So that's the formula for finding the circumference of the circle. 2 pi r. That was 2 times pi times the radius. So we are multiplying the radius by 2 before the x. Therefore, if you are multiplying the radius by 2, it means that if you are giving the diameter and not the radius, you'll be having what? Pi d.
Yes.
Is that okay? So now take this example. You solve and you give me the answer in the chat box. The radius of a circle is 10 centimeters. Find the circumference. Or find the perimeter. Let's make it find the perimeter.
The chat box.
Find the perimeter. This one shouldn't take you like 5 minutes, crowd.
This one. 2.2.
Okay, so take pi to be 22. 22 over 7. Okay, I'm seeing 62.86. Beautiful.
I've sent it to that table that you see.
Okay, beautiful one there. Abraham.
Wow. If you get it to my everyone.
Mistake.
I'm waiting for the rest.
8.
5, 7.
Seems today Brigitta is quiet too. Lisa 62.85, nice. 52 is quiet. Michael is quiet.
Sent it to that table. How do I do it?
Daniel, you are quiet. Basira, you are quiet. Oh, only 3 answers. Okay. So that's it. Okay. So when you are asked to find, nice one, Brigitta. When you're asked to find the perimeter of a circle with a radius of 10 centimeters, it is 2 times pi, and pi is 22 times over 7 times the radius, which is 10 centimeters, and that will be giving us 62.8571. But always run it down to the nearest 2 decimal places. Okay, so that will give you 62.86. 62.86 centimeters. 62.86 centimeters. Nice job, everyone. Nice job, everyone. Now, find the circumference of a circle, or the perimeter of a circle with a diameter of 20 centimeters. With a diameter of 20 centimeters.
62. Answer is 62 to everyone. 62.86.
Okay, nice one, Abraham.
Say, my answer is diameter. You multiply it by 2. What is type is wrong?
Nice one, Ibrahim.
What I said is correct.
You said find what?
The circumference.
Of a circle.
I didn't copy it. The diameter of a circle is 25 in the perimeter. Yeah, 5.
Point.
So if you are given the diameter, in this instance, you have not been given the radius, but you are given the diameter. And the formula for finding the circumference of a circle, when you are given the diameter, is pi d. It is pi d. So it is 22 over 7 times 20 centimeters, and not 2 pi r. If you want to still use the 2 pi r, then you have to divide this 20 centimeters into 2, and that will give you 10. So it will give you the same answer, which is what? 62.86. Just that in the first instance, looking at this circle, in the first instance, the radius was given. That's from the center of the circle to this side of the circle to be what? 10 centimeters. Is that okay? To be 10 centimeters. And in this second instance, the diameter has been given, which is from this side passing through the center. It means that to pass through the other radius centimeters. Is that okay? That means that it is 2 times this 10. That's why in this formula, we have 2 times the radius. 2 times the radius is the same thing here as pi times only the diameter. Radius is 10, diameter is 20. Therefore, to use the radius formula, you multiply the radius by 2 to get 20 before you multiply it by pi. To use the diameter formula, you have the diameter already, which is 20. You don't need to multiply or divide or do anything. You just multiply it by pi, then you get your answer. I hope that's okay. Good. So that's for the formula for the circumference of a circle. But there's more. Okay, so we have these circles. Now, looking at these circles, you could see that this circle does not have any line dividing it. It is a full circle on its own. This circle does not have any line dividing it. It is a full circle on its own. And it rotates, is that okay, on an angle of 360. The angle of a circle, of a full circle, is 360. That's if you are rotating around this circle. You go round, 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 and come and meet it again. And that is what? 360 degrees. That is 360 degrees. That is for the circle. That's everything inside the circle. The angle of this circle is what? 360 degrees. Now, if you take this one too, the angle of this semicircle, that's from here to here, it's not the full 360 that you would have moved if you were walking around this circle. So if you are walking around this circle, you can walk from this side, move through here. Let me use the notation. You could have walked from this side, moved through here to here. And that's what? A full 360 degrees angle. Is that okay? Now with this semicircle, if you are supposed to move around this semicircle, you are going to move from here to this side. We are still talking about the perimeter here. And with this one, it is half the angle of the full circle. Half of 360 is 180 degrees. Is that okay? So in this instance, you are not, if you are asked to find the perimeter of a semicircle, you are not walking around the full circle, but you are walking around the half circle. And that's what? 180 degrees. Now, with this one, you have a quarter, that is a quadrant of the circle. So if you are asked to find the perimeter of this arc, is that okay? Now, the circumference or the perimeter of this arc will be working from here, that's from this side, to working to this side. And with this one, the angle is a right angle, and it is what? 90 degrees. It is 90 degrees. So as you can see from these three examples, you could see that if you are asked to find the circumference of a circle, it can also depend on the angle at which you are finding that circumference. If it is 360 degrees, you are finding the whole circle. If it is 180 degrees, you are finding a certain portion, that's a half of that circle. And if it is 90 degrees, you are finding a quadrant, a quarter of that circle. Therefore,
Off
the fridge.
it. What are you buying?
one
What are
second.
you buying?
Okay, good. So therefore, if I have this circle with this radii with an unknown angle, which we normally call theta. But first, if we have the circle and we are finding the full circumference, you know that it is 360, right? So if you are finding the full circumference of the circle, that would be what? 360 degrees. Sorry for my writing. Over what? 360 degrees. Then you multiply it by what? The circumference that you'll be walking around. That's what? The 2 pi r. Is that okay? So this one will give you 1. Therefore, the full circumference of the circle is 2 pi r. That is 1 times 2 pi r. I hope you are getting the scenario. If you don't understand, give me a no. Then I'll go over it. If you understand, give me a yes. If you don't understand, give me a no. Then I'll go over it. Okay. I'm having one no, so I'll go over it. Okay, so let me clear everything. So this is the circle. And okay, nice. I'm going over. So this is the circle, okay? And to find the circumference of the circle, the formula is, the formula is 2 pi r. Is that okay? Another reason why the formula is 2 pi r is that this circle, you'll be walking around the circle from this side up to this side. That is why you are having what? A 2 pi r here. Now, it's because you are walking all the 360. If you are told to walk around a particular playing field and the angle in the playing field is 360 degrees and you walk around it, you have walked all the 360 over the total was 360. If you weren't able to walk around it and you were able to walk from maybe here to here and the angle inside this area is maybe 60 degrees, then it means that you have been able to walk 60 degrees of the total what? 360 degrees. Therefore, to find the circumference of the full circle, it is 360 over 360 times 2 pi r. Is that okay? This will cancel this and it will give you 1. 1 times 2 pi r is the same as what? The 2 pi r. I hope you get it. Aha. So if you weren't able to walk the full 360 degrees and you are still asked to find the area of the particular portion that you walked, the circumference of the particular portion that you walk, which is from this side to this side, that will be the angle that you walk. That is 60 degrees all over 360 degrees times what? The 2 pi r. I hope you get it. Times the 2 pi r. Let's not use 60 degrees. Let's use another familiar angle, which is 180 degrees. Is that okay? So you couldn't work the full 360 degrees, but you were able to work half of the circle. That's 180 degrees. Therefore, you'll be having 180 over 360 times what? 2 pi r. Now 180 over 360, this one is 1. This one will give you a 2. So you get 1 over 2 times 2 pi r. And this is the formula for finding the perimeter of a semicircle. Half times 2 pi r. That is, you find the perimeter of the full circle. After that, you multiply it by half, since we are looking for what? Half of the circle and not the full circle. I hope you get it now. So with this explanation, you can say that given the formula 2 pi r to be the circumference of the full circle, then any angle that you will get, which is any angle that you get in this circle, which is this side, is what? 60 degrees. Maybe the angle is, no, let's not use 60. Let's use theta. So any angle inside this side is denoted by what? Theta. It's denoted by theta. Therefore, to find the circumference of this particular arc, which the angle will be given, will be theta over 360 times 2 pi r. Therefore, if this angle is 60 degrees, it will be 60 over 360 to be 60 over 360 times what? 2 pi r. And that will give you the circumference of this particular arc. The circumference of this particular arc. Now, if the angle here is 90 degrees, you'll be getting 90. I did that right now. My handwriting is. You'll be getting 90 all over 360 times what? 2 pi r. And we know that 90 degrees in a circle is a quadrant. That's a quarter of the circle. That gives us what? 90. So this one divides itself by 1. It divides 360 by 4. Therefore, the circumference of finding a quadrant is 1 over 4 times 2 pi r. That is the formula for finding the circumference of a quadrant. So the formula for finding the circumference of a semicircle is 1 over 2 times 2 pi r. The formula for finding the quadrant is 1 over 4 times 2 pi r. And the formula for finding the circumference of a circle of any arc, which the angle has been given, is that angle, which is normally denoted by theta over 360, which is denoted by theta over 360 times what? 2 pi r. I hope you get it now.
And
Please, can you mute yourself? Okay. So these are the formulas. I hope you get it now. I want an answer. If you get it, give me a yes. Good, 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 good. Oh, my guys are good. I like that. I like that. Okay, so we will take a question on this. Given this circle, good, good, good. The angle here is 120. Okay, so the angle there is 120 with a radius of 7. The angle is 120 with a radius of 7 centimeters. Find the perimeter of that arc. Okay, so I'll be waiting for my answers. Since you are using a calculator, it shouldn't be difficult for you. Within some 2 minutes, you should be done. Good one there, Kelvin. Good one there, Lisa. Good one there, Abraham. Good one there, Ibrahim. Michael, nice one there.
That means I can eat, right?
I'm still waiting for Brigitta. Okay, Petra, nice one there. Brigitta and Basira, Daniel, nice one there. Daniel Asamoah is in his level with Daniel Dake. I'm waiting for you. Gifty.
Maudina
Gifty,
is in
I'm
the
waiting
group.
for your answer too. Mawunya, I'm waiting for yours. Those copying and pasting answers, I'm seeing you.
Leslie. Maudina is in the group.
Okay, Lisa, so whatever you say, we can hear you, okay? So it's either you mute yourself or you become very quiet, okay? I think this is your first time, so aha, nice one there, nice one there, nice one there. I like it. Hey, Gifty, Gifty, are you in class? I'm waiting for you. Okay, Mawunya is in. Nice one there. Who else? 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 Okay, so let's continue. Today, Gifty don't want to talk. Okay, so we know that the formula is what? Theta over 360 times 2 pi r. Okay, and we know that our theta is 120 over 360 times 2 times our pi, which is always 22 over 7. Always 22 over 7 times our r, which is what? 7. So I'll not bore you with the mathematics calculations and cancellations. You have your calculators there. You just punch it in and you get what? 14.666667 to 2 decimal places is 14.67. I hope you get it. So that's for the circumference of an arc when an angle is given. For the circumference of the full circle, the angle is 360. So it's 360 over 360 times 2 pi, and that will give you the same 2 pi r. Of a semicircle, is 180. 180 over 360 is half, and that will give you what? Half 2 pi r squared, 2 pi r. For a quadrant, that is 90. 90 over 360 will give you 1 over 4. Then you multiply it by what? The 2 pi r. So these are the major formulas that you will find. And when the angle is not either 180, 90, or 360, you use what? Theta, and that will give you, the theta is the angle there over 360, then you multiply and you go your way. Okay, Basira says, hey, is it she or he? Okay, Basira says he is confused. Where exactly are you confused? Can you pinpoint the exact area, the exact part that you are confused? If you can ask your question, I would have explained it for you to understand it well. Is that okay, Basira? Okay, Lisa. Lisa, you can unmute yourself and ask the question. Oi! Okay, I see. Lisa, your hand is up, or you can ask your question now.
I wanted to ask, what if you want to find like the major sector of the circle instead of
Okay.
that small arc?
Okay, I see. So you have, I'll come back to you, Basira and Michael, okay? We'll go through all over again. So we have this. where this side is 120. Is that okay? But you are asked to find this side. I hope that's your question. Okay, so with this one, you know that the full angle in the circle is what? 360 degrees. Okay, you know that the full angle in the circle is 360 degrees. So if you want to find the angle on top here, that will be 360 minus 120. And that will be giving you what? 240, right? Is that okay? So using this 240, it will be 240 over 360 times 2 times 22 over 7 times the line was radius was 7 centimeters. Is that okay? So in this instance, you will not use the smaller angle, but you use the angle that has been given to you to find the bigger one. Then you use the bigger one to solve for the question. I hope you get it. Sometimes you'll be given the bigger one and you will need to find the smaller one before you can solve for this question. Is that okay? So solving for this one, you'll be getting 240 over 360 times 2 times 22 over 7 times 7. And that will give us 29.33333. 29.33. And for the first one, we had what? 14.67. Adding this together, which is 29.33 plus 14.67, will give us what? 44. Is that okay? It will give us 44. Now, if you want to know that this answer is correct, because this 44 is the full circumference, that's the big one plus the small one. We calculated the small one to be 14.67, and now we have calculated the big one to be 29.33. So that will give us what? 44. To know that this answer is correct, you have to find the circumference of the full circle, which is 2 by 22 over 7 by 7. And that will give us 44. You can punch on your calculator. Is that okay? So that makes the bigger circle plus the smaller, the bigger circumference, that's the bigger arc and the smaller arc. When you add them, you'll be getting the what? The full circumference. That's 44 centimeters. I hope that's okay. So we'll go through one more time. Lisa, I hope you are okay.
Yes.
Good. That's nice. Okay, so I'll go through one more time for Basira and Michael. Then we'll quickly look at the area since we have moved through the circumference. Okay. Okay, so as I was saying, this is your circle. We want to find the circumference of this circle. Now let's take it that this circle's length, the length of this circle, that is, you have a school football field. Is that okay? You have a football field, and you want to walk around that football field. You know, when we were kids, we were using our legs to measure the length of walls and the rest. So you'll be counting 1, 2, 3. If you are doing that and you are using it to walk around the whole field, that means that you'll be calculating for the length of the full field. Is that okay? Now, calculating for the length of this full field can be the same as walking from one junction to another junction. Is that okay? So if walking from, let's say, walking around Accra Sports Stadium, walking around Accra Sports Stadium is the same as walking from Kaswa to Malam Junction. Exactly. Kaswa to Malam Junction is a straight line, but walking around Accra Sports Stadium will be in a circle form. So it's the same thing that we are finding here, just that in this instance, this straight line is in a circle form and not what? A straight line. I hope that's okay. Okay, Michael has gotten what he needed. That's cool. Let me go through for Basira. So it's the same as walking around the circle, which is this straight line. So that's what we are finding here. That's the length of this line, or the length of this line turned into a circle, which is this one. So to find the length of this line, you walk from here to here, you'll be getting what? Maybe 12 centimeters. Okay, you can walk around this one too and get what? 12 centimeters. But in some instances, walking around this one, it is a circle, and this one is what? A straight line, which means that there will be some differences in your walking, because this one will be curving here and here and here and here. This one will be a straight line. That brings about what we call the pi. So the pi is that difference, that minimal difference, that 3.14. 3.142 something something something. That's the pi. That's the minimal difference, which is what? 22/7. Exactly. As we started, I made you find the circumference, then you divide by the diameter. Then you get what? 22/7. That's what? The minimal difference. That's the pi there. I hope that's okay. That's the pi there. Now, with this pi, to find the circumference of this circle, instead of walking around and walking around and walking around, we can just walk from the center to a side of the circumference, or you can walk from one side to another side of that circumference. And walking from one side to another side of one circumference and passing through the center is the line called the diameter. Therefore, if you have the diameter, what do we have to do to account for these curves that we have here? You know, this is a straight line, so you just walk straight, but these are curves. So what do we have to do to account for these curves? And that is the pi, the 3.142. It is accounting for these curves here. Therefore, finding the circumference of the circle is pi d when you are given what? The diameter. And when you are given the radius, you walk from here to this one center. But you have one center left, which is this side. That's why you will have 2 of the radius times pi. In mathematics, we don't say 2r pi. We say what? Oh, I was explaining to her and she's gone. In mathematics, we don't say 2r pi, but we say what? 2 pi r. I hope that's cool. So that's it. That's what you are finding, and that's the circumference of the circle. Now, finding this circumference of the circle, you will see that sometimes you will have to walk this side and this side, giving you a 90 degrees. Sometimes you walk this side and this side, giving you maybe something like a 60 degrees. Sometimes you walk half the circle, giving you a distance of what? 180 degrees. Sometimes you walk the full circle, giving you what? 360 degrees. So that brings about that degree thing in this circle, or this mensuration. Hey, did I say mensuration? Mensuration. Okay, mensuration. Is that okay? So that's it about the circumference of the circle. Any question? Any question? Any other question? Okay, so we are done with the circumference, which is the length of the circle. Now we'll be looking at the area of the circle, which is if you have this circle. Now we are not looking at this length that's from here to here, but we are looking at the area inside it. Is that okay? We are looking at the area inside it. So I have this circle. And now, as I said, we are looking for all this side. That's what you are looking for. Exactly. And not just the length of the circle. And in this instance, the area of a circle, the formula is given by pi r squared. Pi r squared. I will explain it. The formula is given by pi r squared. Now, in this instance, we are not finding if we are given the radius. That's from this side to this side. We are not finding the length of the circle so that we'll be able to add this radius and this radius together to get what? Our circumference. But in this instance, we are finding the area in between this place. Therefore, to find the area, it is length times breadth. If you have, what is it called? A rectangle or a square. Oh, what I wanted. So if I have this, it is what? Length times the breadth. Is that okay? So it's the same thing here. We'll be finding the length times the breadth of this circle. And giving two radii, where this side is 7 as the length and this side is 7 as the breadth. If we are walking around this circle, the area in between, it means that we are going to walk this side. Walk to this side. Therefore, to get the area of the circle, you have to multiply two radiuses together. Exactly. As in this one, if you are going to find, you'll be finding two sides together. In this circle, we'll be multiplying two radius together, which will give us the r squared. I hope that's okay. Then we have to account for this curves here. This one is just a straight line, so you don't account for anything. But this one, they are curves. So you have to account for the curve, and that is what? The pi. That is the pi. Is that okay? That is the pi. So finding the area of a full circle is pi r squared. You multiply r twice, then you account for the differences in the curves in the circle, and that is what? Pi. So that gives us what? Pi r squared. Pi r squared. Now, with our knowledge in the circumference of a circle, we can say that if we are walking around the full circle, it means that we are walking. It means that we are walking in an angle of 360 degrees. Is that okay? It means that we are working with an angle of 360 degrees. And that will give us 360 over 360 times pi r squared. Then we are going to get 1 times pi r squared, which is the same as what? Pi r squared. I hope you get it. Now, if you are going to walk half the circle, which is we are finding the area of half the circle, that is what? 180 and not 360. Is that okay? So the angle will be 180 all over 360 times pi r squared. This one will give us 1 over 2. And that will be 1 over 2 times pi r squared. So finding the area of a semicircle is dividing the area of a full circle into 2. That is 1 over 2 times pi r squared. So with this knowledge, we can say that finding the area of a quadrant, that's a quarter, will be what? 1 over 4 times pi r squared, because we'll be getting 90 over 360 times pi r squared. Is that okay? And this one give us what? 1 over 4. So that's finding the area of a quadrant, finding the area of a semicircle, and finding the area of a fourth circle. Area of a fourth circle is multiply the radii, that is the radius, multiply it by 2. That's r squared. If you are squaring any figure, you are multiplying that figure by itself. So r squared will be what? R times r. Then you account for the differences in the circle, that is pi, and that will give you pi r squared. To get the area of a semicircle, it's half the area of a circle. So you get your pi r squared, you divide by 2. To get the area of a quadrant, it is what? 1 over 4 by what? Pi r squared, which is what? A quarter of the circle. So if you have been given the circle with an unknown angle, which is we term as theta. Is that okay? With an unknown angle that we term as theta, we'll be multiplying the theta over 360 by pi r squared. I don't know why my writing is becoming so unbecoming. Okay. Okay, so we'll be having theta over 360 times pi r squared. So any angle you are given, you just insert it there, then you get your what? Your answer. That's finding the area of a circle. Finding the area of a circle. Any question? Any question? Any question? I want to ask, how many of you have done trigonometry? Trig. If you have done trigonometry, give me a yes in the chat box. If you haven't done it, give me a no in the chat box. Trigonometry. Hello. Okay, I'll go through once more. But if you have done trig, give me a yes. Okay, no, Michael. No, Abraham. No, 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 no. Wow. No, 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 no. Then I can't treat this one because this one is a trig. Okay. Okay, okay. So we have to treat trigonometry before we can come and apply it into the circuit. Okay. Okay, so I'll go over once again. I'll go over once again, then we continue. Okay, so this is your circle, and we are using our knowledge. Okay, Lisa has done trick. That's nice. We'll be using our knowledge from what? Finding the perimeter of a circle. That's what we'll be using here. Our knowledge from finding the perimeter of a circle. Now we have a radius of what? 7 centimeters, or let's say we have a radius of the circle. And we are to find the area in this circle. That is, in this instance, you are not finding the length of the circumference. That's from walking around it. But this time, we are looking at the area inside the circle. So for example, like the rectangle that I drew, if you are asked to find the circumference of a rectangle, it is what? 2L plus 2B. So 2 of the length, that's the length. This is one length, this is another length. You have 2 lengths. Then you add it up to what? These 2 breadth. Then you get your perimeter. But to get the area of this rectangle, you have to multiply the length by the breadth. Is that okay? So you multiply the length by the breadth, and it's the same thing as multiplying this length by this breadth, since they have the same equal side. So you multiply this length by this breadth, this length by this breadth. Is that okay? That is finding the area of what? The rectangle. Now, if you have the area, if you have the perimeter of the circle, now you have your radius. Perimeter, you do what? You multiply the radius by 2. That is, you add the radius twice. Is that okay? You multiply the radius by 2. That is, you add the radius twice. So if you have a radius of 7 centimeters and you are finding 2 pi r. Now, as I've already said, pi, you should remove it from here and take it as the abnormalities that you see around the circle. That is these curves. You see, it's not a straight line. So this pi is accounting for that curves. If you have done elective math, like, you would have gotten to know how we actually calculate for the pi. But this is common, so I will not bore you with that thing. But the pi is that abnormalities. Finding, you can divide this circle into 32 equal parts. Then after dividing it, you'll be getting that 3.14. Let's not go there, okay? Let's just do the comma. So just take the pi out. Now we have the radius of 7. Now, what we need to do is that we are walking around this whole circle. So it means that we'll be walking from here up to here. That's why I'm multiplying this radius by 2 to get the diameter. Is that okay? So when you multiply the radius by 2, you'll be getting what? 14. You're getting 14. But to find the area of this circle, you don't have to multiply the radius by 2, but you have to multiply the radius by itself, because you'll be working inside this circle, which is this area, and not this area. So for the rectangle, for instance, it is length times breadth. Therefore, for the circle, it is also length times breadth. And the length and the breadth of this circle is the radius that we'll be having. That is this radius and maybe this radius. Is that okay? That's the length and the breadth that we'll be having in this question. Is that okay? So to get the area of the circle, you multiply the radius twice, which is 7 squared. If you are multiplying it twice, it means that we are squaring it. So 7 squared is equal to what? 7 by 7. And that's equal to 49. So in this instance, you are not adding the 7 twice. That's 7 plus 7. 7 plus 7 to give us what? 14. But we are multiplying the 7 twice, which will give us what? 49. That's the difference here. So with the area of the circle, you multiply the radius twice. That will give us 2 pi r squared. Is that okay? Multiplying the radius twice is r squared. If you are multiplying it thrice, it will be r cubed. Is that okay? So multiplying the radius twice will give you what? Pi r squared. The pi, as I've already said earlier, is there. It's making up for the curves here, the curves here, the curves here. Is that okay? So r squared, that is 7 by 7. So that's the area of a circle. Now, if you have been given the area of a circle, you have been asked to find the area of this quadrant. And we know that a quadrant is bounded by an angle of 90 degrees. Now, a quadrant in a normal sense is a quarter of a circle. And a quarter of a circle is 1/4. If you are finding a quarter of anything, a quarter is 1/4. So finding a quarter of this circle will be 1/4 times pi r squared. Is that okay? But we don't want to use this quarter here, but we want to use the angle there. Therefore, using the angle there, which is, we normally represent it by theta. We divide it by the total angle of the circle, which is 360 degrees. Then you multiply it by what? Pi r squared. In this instance, we know that our theta is 90, which is a quarter of 360, all over 360. Is that okay? When you divide this one, you get 1, you get 4. And that will give us what? This 1/4. So that's how we got this 1/4. That is what? The 90 degrees here over the total 360 times pi r squared, giving us what? 1/4 times pi r squared. With the semicircle, you are using only half, you are finding the area of only half of the circle. Therefore, the angle here is 180 degrees. Semicircle, we know that is half. So find the semicircle is half of pi r squared. It is half of pi r squared. Why did we get half of pi r squared? That is 180 degrees over 360 degrees times pi r squared. 180 over 360 will give you 1/2. And that will land us with this formula, half pi r squared. That's for semicircle. This is for a quadrant or a quarter of a circle. Then pi r squared is for the full circle. That is the area. So a question for you. Any question? If you don't have any question for me, I have a question for you. I have a question for you. Okay, since there is no question for me, there is a question for you. It's an angle of 60 and a radius of 7. Find the area of this sector. Find the area of the shaded sector. Find the area of the shaded sector. I'm still waiting for the answers. Nice one, Lisa.